Okay guys, let's take a look at today's lesson. So we're going to be focusing on degenerate conics. You probably have not looked at that topic, at least in Algebra 2. This is new. So let's talk about what is it? What is a degenerate conic? Let's first start with just regular conics, just a little bit of a review. So the general equation of a conic, this is a general equation where it's all written out and it's equal to 0. Notice how I have an ax squared and then a cy squared and then a dx ey plus f. We're missing this term right here, which you're going to learn about tomorrow. It's bxy, so that's a rotation where the conics are rotated. So this is the general form of non-rotated conics. Okay, just the ones that we're used to, the ones we've been using for a long time. And so this is our normal equations. We know we have two forms for parabolas. We have a form for circle, 2 for ellipse, 2 for hyperbolas, etc. So those are just our norm. And we get those from a double napped cone. I know it sounds weird, right? It's just basically one cone. They're touching at the ends of the cone. And so we know that if we were to cut straight across, we would get a circle, right? And if we would go this way, we would get an ellipse. And if we would, cut through like this, we would get a parabola. And then if we cut straight down, we'd get a hyperbola. So we've seen those before. Well, there are other things that can happen besides those things. And this puts us into the realm of degenerate conics. So it is possible for the slice to go straight through the middle, which would create two intersecting lines. That's possible. It is possible for the intersection to go right in where the two cones meet, and that would give us a point. It is also possible for it to slice this way, which would give us a line. So there are different ways it could be sliced besides what we're used to. Now let's talk about it in terms of what we're looking at. So if we see an equation and we think it looks like it's either going to turn into a circle or an ellipse, and we work it through, and it turns out to be equal to 0, that means it's degenerate. And that means that if it was supposed to look like it's going to be a circle or an ellipse, and we do our completing the square, and it turns out to equal 0, then it's going to be a point. It's going to degenerate into a point. Okay, and it's not going to change. I mean, I'm telling you exactly how the formatting works. This doesn't have to be a guess as to is this a degenerate or not. It's basically if after you complete the square you get, this side is 0 right here instead of a 1 or whatever, then it's a degenerate. All right, so a hyperbola, if the equation looks like it's going to be a hyperbola and you work it through and it's equal to 0, then it's going to degenerate into two intersecting lines, and we have to find those lines. And I'll show you, we'll do an example of actually both of those. The type of degenerate that we're really not going to encounter because we don't recognize that it's a degenerate is one who's created from a parabola. The reason that we're not going to recognize that it's a degenerate is because A, B, and C, these coefficients are equal to 0. So if we had 0x squared and a 0y squared, we would not even notice that, right? If they give us just an equation, and unless they wrote it there for us, I mean, I guess they could write 0x squared and then we would recognize that it's a degenerate parabola. But we're really not going to normally see those, because what happens when A, B, and C are 0 is it's either going to turn into one line or two parallel lines. And so this type of degenerate we're just really not going to encounter. Does that make sense? Because we would not notice if it had, if 0y squared or 0x squared, because it wouldn't even be there. So the ones we're going to be dealing with are the ones that are circles, that look like they're going to be a circle, ellipse, or hyperbola. Those are the ones that could turn into a degenerate conic. All right, questions so far for me? Okay, let's go to, we have just a few examples. I have 3 examples on the next page, so let's go over there and take a look, see what we have going on. All right, so the first one, when we look at it, it looks like I have an x squared, a positive x squared, and a negative y squared. So to me, that looks like it's going to be a hyperbola. Right? That would be a hyperbola. One of them is negative, one of them is positive. So let's work through and see what we get. So we're going to separate them like we normally do. We're going to get the x's together. We're going to get the y's together. Notice that the x's, before we can complete the square, we're going to have to factor a 9 out. So we're going to do that. 9 times x squared plus 2. And here we're going to have to factor a negative out. I'm just going to write it as a -1 so it's really clear what it is that we're doing. So -1 times y squared minus 6y. All right, so let's complete the square. So I have 2, which is 1. I square 1, I get 1. So I add 1 here, but I didn't really add just 1, right? I added 9, so plus 9. Over here, I have 6, which is 3. 3 squared is 9, so I add 9. But I didn't really add 9, did I? I subtracted 9. And we notice that this quantity is going to be 0. So this is a degenerate hyperbola. Okay? And if you look at the last slide, what is a degenerate hyperbola going to degenerate into? What's it going to become? 2 intersecting lines. So that's what's going to happen. So we need to find those 2 intersecting lines. All right, so let's factor and get this looking as normal as we can. So x plus 1 squared minus... Okay. So when we have this situation where it's a degenerate hyperbola, what we're going to do is we're going to take the negative piece, which is this piece, and we're going to move it to the other side to make it positive. So I have 9 times x minus 1 squared equals y minus 3 squared. Squared. X, oh yeah, it's a plus, thank you. X plus 1. Okay. So I've moved that over. We take a look at that, and what we would do at this point is we're actually going to square root both sides. Okay, when we square root both sides, we're going to be left with a plus minus 3 times x plus 1 and a y minus 3. Okay, so let's get it to look more like a line. I mean, I just want to move things around. We're done. Those are the 2 lines, but I just want to kind of move things around. So we'll do y minus 3 equals plus or minus 3 times x plus 1. So those are our pair of intersecting lines. Now, we'll need to graph them from, we're not going to have to graph everything, but I do want to just practice graphing the degenerate conic. It's going to be way easier than graphing a regular hyperbola, right? We're just going to be graphing 2 intersecting lines. So let's do that. Let's go ahead and do a graph of our conic, our degenerate conic. So let's see. We know we're at what, a -1, 3. That's the point that these 2 lines have in common, is a -1, 3. And our slopes are plus and minus 3. One line is a plus 3, one's a minus. So let's just kind of go. So we have 1, 2, 3, 1. So here's one line. And then we have 1, 2, 3, and going -1. So that's that line. So there is our degenerate hyperbola. Okay, we okay with that? Yes? All right. So let's look at our next one. I need a little bit of room. Does everybody have what they need? I need to erase just a little bit. I'll just erase this graph. Okay. So let's work on the next one. This looks like it's going to be an ellipse. Do we recognize that? We have an x squared and a y squared, and the coefficients are different. That means it looks like it's going to be an ellipse. Let's see what happens. So we're going to do the same thing we always do. We're going to group the x's together. Then we're going to group the y's together. Move the constant over. Okay. The x's looks like we need to factor out a 4. Okay, so we are ready to complete the square. So we have 2. Half of 2 is 1. 1 squared is 1. So I add 1, and then I'm going to add 4. right? I'm going to add 4 over there. So then I half of 2 is 1, 1 squared is 1, add 1, add 1. So I have 4 times x minus 1 squared plus y plus 1 squared equals -1. Okay, that's not 0. This is not degenerate. Okay, so we see, well, if I multiplied everything by -1, would that fix things? What kind of conic do we have where both of these are negative? Do we have one? No. No. So this is an imaginary ellipse. Can you believe it? Isn't that fantastic? Okay, it doesn't matter if it's -1 or -20. If it's negative and it's supposed to be an ellipse, it's not there. It's not there. And I'm sorry, I know some of you really want to graph an imaginary ellipse, and you're probably thinking, wow, how would we graph that? It would be in a complex plane, and we really aren't going to do that. I'm sorry to disappoint you, but we're not going to really graph it. So we're just going to be satisfied with saying that this is imaginary ellipse. An ellipse that's, not an ellipse. Well, what would happen over here with this hyperbola if I was equal to a negative number? Would that be would we be done with that? What would we do? Yeah, because they're different, right? So if we were over here with something we thought was a hyperbola, and it turned out to be equal to -1, we would just multiply through by -1, and it would be a hyperbola, right? We'd be okay. It's just with ellipses and circles, we're kind of not okay. We don't have a conic that has 2 negative squared variables. Okay? Well, it's actually degenerate is a specific form. It's when it's equal to 0. This is just imaginary. So yes, today we get to experience degenerate and imaginary conics. Who would have thought? All right, last one. So we look at this one, and again, okay, it looks like it's going to be an ellipse. Let's see what happens. So let's do our work. We'll group the x's together, group the y's together, move the constant over. Okay? Ben, you need to stay with me. So then we need to factor the 2 out. Okay, so I'm going to take half of 2, which is 1. 1 squared is 1, so I would add 1 and add 1. Okay, so half of 6 is 3. 3 squared is 9, so I add 9 and make a little room right here. So I add 9 and add, but I'm not adding 9, am I? I'm adding 18, right? So adding 18. So this is going to be 0. So we have another degenerate. This one is a degenerate ellipse. What does a degenerate ellipse degenerate into? Just a point, right? It's just a point. So let's clean this up and let's talk about that. So we have 2 times y minus 3 squared equals 0. Okay, so here's our ellipse. So we could go through and do some algebra to it and mess with it, but I really just want you to think about it for a moment. There's only one set of points that's going to cause that to go to 0. There's just one. Every time, there's just one set of points that's going to cause it to go to 0. And what will those set of points be? Yeah, they're going to be the opposites, right? It's going to be a -1 and a +3. Those are going to make it go to 0. So we don't have to do any algebra. I mean, you can if you want to, but we don't have to do anything to discover that. We just look to see which would make both of these 0, and that's going to be a -1 and a 3. And that conic is going to be really easy to graph, right? So let's graph it. -1, 3. Woo, there's my degenerate conic. Okay. How are we on this lesson? We okay? All right.